8.3. We are going to continue working with trinomials and factoring them. So trinomial means we have three terms, and we're trying to figure out what groups of numbers multiplied to create these three terms. So we would have two groups of numbers here that are multiplying up, and when they multiply, they make this, okay? And so we've been working with the big X. That's what we practiced. So we were really focused on how do we fill this out, especially finding our side numbers, because once we find our side numbers, the big X is just a way of organizing our work. And then we're going to take some information that we get from this, and it's going to help us fill out our answers, okay? So the first thing we always want to do, we're going to take our first number, which is a 1 in these. So we haven't seen like anything other than a 1 up front here, our leading coefficient. It's really our first number times our last number. So 1 times -4. And the shortcut here is when there's nothing in front, I mean, it's a 1, and 1's not going to change anything. So it's not going to change that -4. And then our middle term, -3, we use below. And we're looking for what would multiply to make a -4 and add or subtract to make a -3. And so you could go back and look at the chart, which I think I have down here. I don't have for 4 though, because it's really just, so for 4, it's 1 times 4 and 2 times 2, and 1 times 4 is going to work. Okay, so 1 and 4, and we have to figure out our signs. My bigger number is going to have the same sign as my bottom number. And if my top number is negative, then only one of my two numbers here needs to be negative, because if they both have the same sign, they're going to multiply to make a positive up here. Okay, so my numbers are 1 and -4. And we've been practicing this all week. Here's our next step. How are we going to use this 1 and -4? Well, this helps us find a special pattern of what multiplies to make our last number and combines to make our middle number. And in this special pattern, those numbers simply get filled in with our variable, right? So our variable here is b. So in both groups, it was b. And in my first group, I'm going to say it was b plus 1. And in my second group, it's b minus 4. So here's where my 1 came from that I put here. And here's where my -4 came from that I put here. And by following this special pattern, it helps us fill out two groups of binomials that multiplied up to make this. So this is my answer. So once I filled this out, it's really easy to get from here to my answer. I'm taking my variable plus 1 and my variable minus 4. If I were to go back and multiply these back up, let's see, we would do b times b and get b squared, b times -4 to get -4b, 1 times b to get positive 1b, and 1 times -4 to get -4. And watch what happens when I combine these. B squared minus 3b minus 4. And this is what I started with. So I'm just breaking this number down into, I'm breaking this trinomial down into what multiplied up to make it. So 1 and -4, when we do the big X, that's how we kind of do the work to find our answer. So let's take another example here. Let's take a look at another example. So remember, our last number is going to go on top, and that means we're trying to multiply to make 18. And then our middle number goes in the bottom. That's a -9. So I want to know what would multiply to make 18 and combine to make a -9. So if I look down at my chart, for 18. So here's 18. There's the 9 that I'm trying to make. So 3 and 6 are my two numbers. 3 and 6. And they would both need to be negative to make a positive up here and a negative 9 down here. So now that I have my side numbers, I'm just going to take my variable and my first side number, it doesn't matter what order, and my variable and my second side number. So if I did x minus 3 times x minus 6, if I work that out, I would get x squared minus 9x plus 18. Think about it like this. If I were to take, this is a very simple example, but if I were to take 24 and break it down, I could break 24 down into two terms that multiply, two factors that multiply to make 24. Let's say 3 and 8. So 3 times 8 means the same exact thing as 24. It's the same value. Okay, or if I did 20, I could rewrite that as 2 times 10. And think about, if I had a $20 bill, that is worth the same amount as having two $10 bills. So these are the same value. X plus 3 times x, or I'm sorry, x minus 3 times x minus 6 is the same value as this. We've just written it differently. We've factored it down. So let's see another example here. Negative 6 goes on top. And this is a negative 1. There's a 1 there. So negative 1 goes on the bottom. I'm looking for what will multiply to make a negative 6 and combine to make a negative 1. It should be a negative 3 times a positive 2. A negative 3 times a positive 2. So once we fill out our side numbers, the only extra step, we've been practicing this all last week. The new step here is that we can say m minus 3 times m minus 2. And these two things multiplying is the same as this up here, as our whole equation. The same way that that 20 is the same thing as 2 times 10. We follow our special pattern here on our x to help us find that. So for this one, it's going to be 3 times 1. So we're saying n plus 3 times n plus 1. The hardest part about these is filling out the big X. If I'm multiplying to make 6 and adding to make, multiplying to make 5 and adding or subtracting to make 6, then we could use 5 times 1. I can say 1 times 5, I can say 5 times 1. Because these two groups are multiplying, a plus 1 times a plus 5. And notice that I'm writing these side by side. If I write them, some students, and it's kind of hard to do on Delta Math, but like on physical paper, I would have some students last year that would write their answers like this. This doesn't mean anything. That's not telling me anything. This is telling me that a plus 1 is multiplying with a plus 5. That I can do something with. This is just, I don't know what this is. This is just, you've written two quantities. They don't mean anything to me. So make sure your answers go side by side here. And because it's multiplying, the order doesn't matter. So if you do a plus 5 times a plus 1, if you write it in that order or if you write it in this order, it's fine. It doesn't really matter. Think about how 3 times 4 is the same exact thing as 4 times 3. You still get 12. Here's another good example. We're going to put 18 on top and negative 9 on the bottom. This will be a negative 6 times a negative 3. I think we already did this one. So n minus 6 times n minus 3. So in this one, we have a 2 goes on top, multiplying to make 2, adding or subtracting to make 3. 1 and 2 are our side numbers, and once we have our side numbers, we're pretty much done. No extra work here. This is a special pattern that when we figure this out, it helps us fill in that pattern there. And it works like this every time when there's no number in front. If there is a number in front, there's some different work that we have to do. But for these ones, no number in front, no extra work. So here I'm looking for what would combine to make negative 14 and add to make positive 5. It's going to be a 7 times negative 2. 7 minus 2 is 5. 7 times negative 2 is negative 14. So we can rewrite this as a plus 7 times a minus 2. It means the same thing. It's the same value. Okay, last couple examples here. This one we're going to put a 6 on top and a negative 7 on the bottom. We should be using a negative 6 times a negative 1. And once we find our side numbers, m minus 6 times m minus 1. And finally, here we have 20 on top, negative 9 on the bottom. And let's see, that would be a negative 4 times a negative 5. And again, you're welcome to use the chart. It'll be posted there. But, here's my 9 that I was looking for. And that was 4 and 5 that make 9. So negative 4 times a negative 5. So now I'm saying x minus 4 times x minus 5.